All right, second example. For second example, we're going to start off the same way. We're going to start off choosing a variable to eliminate. Now, z seems like a reasonable possibility because we do have a freebie there. Y would also be a reasonable possibility because we do have a freebie there. X would even be a reasonable possibility because we do have a freebie there. So as we compare which one to do, I would notice that my z's have the same value. They need to become opposites, so not a huge deal there. The y's, well, I'd have to multiply by -4. The x's, well, I'd have to multiply by -2. I'm thinking the z's are probably the best bet. Now, I do want to point out that there's not a right or wrong answer here when you're making your decision on which variable to eliminate. Now, there might end up being an easier way, and you might pick wrong, and that's okay. But take the time to at least try to optimize your work. So we're going to try to eliminate z's. We're again going to make this notation here that I'm going to try to get down to 2 equations, 2 unknowns. That's my goal. I'm going to copy down the freebie. So I have one equation here that's already missing the z. Oops, not -1. I don't know why I copied that down. Helps to write down the right thing. Now let's look at the other 2 equations. I need to somehow get rid of the z's from them. So the best way to do that is going to be to multiply one of them by -1. So that means off in scrap paper land, I'm going to copy down that original second equation. In the original third equation, I'm going to multiply by -1, giving me -y, positive 4z, and positive 3. Once I add that together, I get 4x minus y equals 2. And I'm going to copy that over here into my 2 equation, 2 unknown spot. Because now I'm going to pause again and say that was the only thing new to this lesson. Now I'm back to 2 equations, 2 unknowns. At this point, I'm going to ignore everything else over here. All that doesn't exist. All that exists now is the 2 equation, 2 unknown system that I want to solve. So I'm going to look at that and say I can eliminate the x's or the y's. Doesn't really matter. I'm going to say let's choose the x's. Why not? We'll multiply by -2 in the top equation. That's going to make him look like -4x minus 8y equals -2. I'm going to copy down the second equation. That way I'm keeping my 2 equation, 2 unknown system together. I'm going to add those together. -4x and 4x is 0. I'm going to get -9y equals, well, 0. So that's pretty nice. Y must be 0. Remember, we're going to keep on solving the 2 equation, 2 unknown system. So now I need to find x. Our 2 equation, 2 unknown system had x and y, and I already know what y is. So I'm going to plug this back somewhere else within my 2 equation, 2 unknown system in order to get the x. So that's 2x plus 4 times 0 is 0 equals 1. So x must be, 1/2. That's all right. We can have a fraction. Now that we're done with our 2 equation, 2 unknown portion of the system, now we want to find the third variable. We're looking for z. We have x and y already. So we look back to the original problem and look anywhere up there for a z and plug in the necessary variables to solve for it. So I'm going to go back to the original second equation where we had 4 times x minus 4 times z equals -1. 4 times 1/2 is 2. If I subtract the 2 to the other side, I get -3. And dividing by -4 gets me 3/4. So if I write this now as an ordered triplet, I'm going to have 1/2, 0, 3/4. Now this fraction answer, I'm probably going to want to check my answer on this one. So let's go ahead and get out our handy dandy calculator. And let's talk about checking our answer. What I would suggest doing for checking your answer here is to actually use the variables in your calculator. And you can do this with the graphing calculator or with the scientific calculator. I'll go over that in a second as well. We're going to convince the calculator that the x value is 1/2 by typing 1/2 followed by store, which is right above on. And then I'm going to type x by doing alpha x. Enter. I'm going to convince it that the y value is 0 by doing 0 store alpha. The number 1 has the y there. So we've stored 0 into y. And then I'm going to store 3/4 into z. In doing this, I'm going to go ahead and scroll back to my original problem now. This is going to make checking our work a lot easier because now I can just type the original problem of 2x plus 4y. When I hit enter, I'm hoping to get 1, and I do. So then I check the second equation of 4x minus 4z. I'm hoping to get -1, and I do. Then I check the third equation by doing y minus 4z. I'm hoping to get -3, and I do. So this does check out. I get the right answer here. So let's talk about doing the same thing with the scientific calculator. It's going to flow pretty much the exact same way, so I'm not going to go through all the steps. But I do want to point out, though, that if we do 1/2 and then store is just above on again, the x in this case is right above store. We hit that once we store it for x. Now when we try to store for y, when we hit the variable once we get x, but if you hit it again, you get y. And so we can do the same thing for the z. We can type 3/4, and then we can store that. To do z, hit that button 3 times. And then same thing for retyping it. So we can retype it by doing 2x plus 4y, and we should get 1, and we do, and you can go through the next 2 equations as well.